Hi everyone, welcome back to JavaScript Bytes, where we do cool things in bite-sized chunks. Imagine a situation: you write some JavaScript, run your code, and boom, this is undefined. Or sometimes it's a window, or an object, or a button. If you have ever yelled, "What the hell is this?" or something similar, you're not alone. In this video, we are finally going to solve the mystery of this keyword once and for all in regular functions, methods, callbacks, arrow functions, and more. This is a special keyword in JavaScript that refers to the current context, but that context changes depending on how your code runs. No matter your level, if you want to finally understand how this works without confusion, this is the one video you'll want to watch all the way through. Before we write any code, let's understand something fundamental that shows up everywhere in JavaScript, the global execution context. So, what is it? When your JavaScript code first runs, like when you open an HTML file in the browser or run a file in Node.js, it enters a default environment called the global execution context. Think of it like the very first container where everything starts. Inside the global context, there is also a global object. This object is automatically created by a JavaScript engine and gives you access to things like built-in functions and variables. In the browser, that global object is called window. In Node.js, it's called global. And when you are not inside any function, you are in this global context. So using the this keyword at the top level refers to that global object. But that behavior changes depending on where and how your code is executed. Let's now go and see that in action. We'll start our journey with Node.js. So let's start by creating a new folder for this project. Let's open it in Visual Studio Code. Let's create a new file here. Inside index.js, let's see what's the value of this at root level. Note that in Node.js, the global object is called global, but modern JavaScript gives us a universal name for the global object in all environments called global this. In Node, both global and global this refer to the same thing. To avoid Visual Studio Code not even letting you type global, we'll use global this instead. So if you are following along, type with me or just continue watching. Let's try executing this code and see what we get. And here's a very surprising result. This is an empty object and this dot name is undefined, even though our first line was assigning global this dot name to be a node global. So what's going on? Let's break this down. So in Node.js, every file is treated as its own module. This means when your code runs, it's not actually in the global scope. Behind the scenes, Node wraps your file in something like this. So even though it feels like you are writing top level code, you are really inside a function. And inside functions, this behaves differently. It doesn't point to the global object. Instead, at the top level of a common JS module, this is the same as module.exports. That's why it's an empty object like this that your module can use to export values. And since this is not equal to global this, it won't see the name property we added. And that is why we logged global this properties separately. And you can see right over here, global this.name is correctly written out as node global, just like we expected. And this is the entire global this object with a lot of inbuilt functions. So you must be wondering, when does this actually refer to global in Node? Well, there are two special cases. First one is Node's REPL or read eval print loop of Node.js, and you can also consider it to be the interactive CLI. You can bring this up by just typing node without file name. Here we are in REPL. So in the REPL, you're running code directly at the global level, no module wrapper. So this is the global object. If I do, it prints out true because this is now correctly pointing to global. And if I type this, you can see it print out the same thing as we saw earlier when we typed out global this. The second special case is ES modules or ECMAScript modules. And you might think that top level, this in the NES module would be global or empty strings like CommonJS, but it's actually undefined, just like in browser strict mode. Let's change our project to be NES module and see what happens. So by default, the file is CommonJS. I just change it to ECMAScript module by selecting module as value of type in package.json. And now if I exit out of this using Control C and do node index.js, you see there is an exception on this name because this is now undefined. Cannot read properties of undefined. So for Node.js, if you're ever unsure what this is pointing to, just log it. And remember, in Node.js, top level this is almost never the global object unless you are in REPL. In normal files, use global or global this when you need the true global scope. Now let's see how this behaves in the browser and compare it with what we have seen in Node. So still in the same folder, let's create an HTML file. Okay, since we are in Visual Studio Code, adding a boilerplate code is very simple. It's just like typing HTML, selecting the second entry, and providing a title. Okay, we'll be writing a browser JavaScript inside the script tag. Here it goes. Okay, now let's open this file in the browser and see what we get in the DevTools. Okay, you see this is equal to the window object. And if I expand this, you can see the entire window object with all of its built-in functions are available here. And that's because in the browser, window is the global object. And this at the top level refers to it. We can actually verify that real quick. So if I go back here and add another line. Okay, I'm going to compare set timeout of this with set timeout that we get naturally. And let's see. And here we are, it's true. And that's because set timeout is part of the global object. Now let's look at how this behaves inside a regular function. All right, if we are not in strict mode, this should log the global object, so that should be window. Let's confirm that. Oh, sorry, I forgot to call this. And here we go. We are seeing the window object being logged from inside the regular function. But what happens in strict mode? Let's try enable it and see. And to do that, we need to use strict in the script tag. So if I go back and refresh, all right, this time we see that this is undefined. Why? Because in strict mode, regular functions do not default to the global object. This is one of the most important things to remember. Same function, different result, depending on the execution context and strict mode. However, note that this applies only to functions. Strict mode does not affect the value of this at the top level in global scripts. It would still point to window object. In case you are still fuzzy about strict mode and this keyword, let me explain. In non-strict mode, if you call a regular function without any object, this automatically points to the global object, like window in the browser. But in strict mode, JavaScript prevents that fallback. Why? Because silently assigning things to the global object can lead to hard to find bugs. For example, inside our regular function, if we do now, in non-strict mode, we have just added value to the global scope, even though that might not have been your intention. So strict mode stops that from happening by making this undefined in functions that aren't bound to anything. That way, if you mistakenly write to this, you get an error, not a silent bug. All right, I'm going to get rid of this line and move on. And now we are going to define an object with a method in it. Let's try it out. Okay, here this refers to the person object because we are calling it with person.sayHello. That's why you are seeing the entire person object being written out. Now let's pass that method as a callback to another function and see if the behavior of this changes. Let's evaluate the result. All right, we got the first console log to execute and where we found this is undefined. And then we got this exception because we were trying to access property name of undefined. Why did that happen? Because when we pass say hello as a plain function, we lose its original context. It's just a regular function now, not attached to any object like person. So this becomes undefined in strict mode. In fact, say hello is not part of person anymore. It's now executing in the global execution context. So if I remove use strict command over here, you're gonna see this becoming window. But I'm not gonna do this in interest of time. Let's move on since we have a lot of ground to cover. Let's now try and use person.sayHello as a click handler. For that, first I'll add a button element in body. Okay, next I'm going to define a click handler. Now note say hello could be a function defined outside an object, but I'm continuing to use person.sayHello as example as it goes one step further to demonstrate how this changes when a method of an object is used as callback or event handler. Same would apply to a function defined in script tag directly. So let's see what the response is. Oh, I'm getting this exception, so our handler is not being bound. So we need to make a change and comment out this line. Now if I go here and press click me, now things get interesting. This is referring to the button, not the person object. From the same function, inside say hello, this is the button element. And the reason is that's how DOM event listeners work. Inside event handler functions, this refers to the element that triggered the event. Let's go back to code. So even though we passed person.sayHello to the event listener, it didn't actually carry the person object with it. Remember, once we pass that method like this, it's just a plain function. It's no longer bound to the person, it's in the global context. So if strict mode is on, this becomes undefined. If strict mode is off, that would be window. But here's the twist. The browser doesn't use it as is. It actually replaces this with the button by using a built-in JavaScript method called .call. That's right, under the hood, it's as if the browser did something like this. That's how you can do that yourself. Now let's give it a try. And you would notice we are seeing inside say hello, this is button, even though we haven't clicked the button yet. So if I click the button, you see the thing gets repeated. So these two lines are coming from this call over here. So call is a very interesting method available on all functions in JavaScript that lets you manually set what this refers to. Sounds unbelievable. Let's give another try. So if I replace this button with person and do the same thing again, you would see now we are getting the person object. You can apply this technique on any function, call any function using call function and pass any object to become this. I hope the relationship of this keyword with functions and callback functions is clear by now. So time to add yet another twist by introducing arrow functions in our story. Arrow functions have a different relationship with the this keyword, and it's worth understanding as they are one of the most useful features in modern JavaScript. And despite being functions, they behave quite differently than regular functions. So let's see that when we say arrow functions behave differently, what does that actually mean? At first glance, you would think the arrow function is inside the yet another object. So it should print Casey, right? Let's confirm. And interestingly, we don't see anything being printed at all. So let's make some change to our code. And instead of this dot name, let's print this directly. So if I refresh and we see window object is being logged. This is pretty counterintuitive, right? The key mistake is thinking that this comes from the object the function is in. But in JavaScripts, objects do not create scope. In JavaScript, only functions, classes, and global or module code create what we call lexical scopes, places where this can be inherited from. Okay, let's try and fix that. Since I mentioned that objects are the only bad egg that don't create scopes, but functions and classes do, let's try wrapping our arrow function inside an object method and see if something changes. And now it works. See? But why? Because say hi is now defined inside greet, and greet is a regular function which gets its own this, in this case, yet another object. And since a regular function creates a lexical scope, arrow function correctly inherits this from greet scope. Now let's try using the arrow function as a callback function and see if things remain the same. So I'm going to add another function here. So in this example, the arrow function is inside a regular function and is being used as a callback. So it inherits this from the counter function, just like our previous example. That's why it works. This correctly refers to the counter object and is correctly logging the count to the console, like this. So that is the working example, but I am really itching to show you an example that would fail. So let me comment this out and write another one. Okay, let's see if it works or not. And you can see it is failing. And why is it failing? Let's just output this. Oh, mistake is over here. Start. And you can again see it is now logging window object or the global object instead of yet another object because we tried to use the arrow function directly since it was not wrapped in anything. It did not pick yet another object as this. Instead, it went ahead and found the nearest scope, which was the global object, and is logging it continuously in the console. If the start function had been wrapped inside a regular function, that would not have happened. So I know it's taking a bit of time, but I really want you to show the difference between class and object as most of us don't consider them different at all. A mistake that splashes in our face when we try to use this, particularly with arrow functions. So bear with me for one more example. Right? Let's see what we get in our console. And class greeter name is Dawn. This is the interval logs from the previous one, but this is the line that we were talking about. So if this is something that surprised you, that two examples look almost identical, but one works and one fails, why? Because classes create a new scope, just like functions do. So inside the class, the arrow function inherits this from that class scope, and it correctly points to the instance. But the object literal doesn't create any new scope. So this falls back to the global or module scope and it breaks. This is perfect reminder. Arrow functions care about scope, not structure, and objects aren't scope. So here's the rule to remember. Arrow functions don't get their own this. They inherit it from the nearest enclosing function or class they were written inside. Objects don't count, they are just containers. If you remember just one thing from this video, arrow functions follow lexical scope, not object structure. That's why this behaves the way it does and why it's so powerful when used correctly. Right, we are very close to the end. This is the last part. So another way to fix context laws is using something called bind. So let me show you an example. I'm going to remove this start call so we don't keep getting those annoying logs. Okay, let's see what the result of our calls is. And we see there's an exception. If we go to the source code, we see the exception is coming on this dot name because this is probably undefined. That's what it says. Can't read properties of undefined. And I'm pretty sure it's happening on this call. So let's say if I comment out this call and let the next one continue, let's see what happens. And now A says object A. So let's see what happens. In JavaScript, when you pass a method like object a.speak as a callback, you're not calling it immediately. You're handing over the function without its original context. This means this inside speak doesn't point to object A anymore. It defaults to undefined in strict mode or the global object otherwise. So the line without bind call breaks because this dot name is now undefined. Object a.speak lost its connection to object A. But when you use .bind object A, you're locking this inside speak permanently to object A, no matter where or how it's called later. That's why the second line works. Speak still knows it belongs to object A. Think of bind like permanently assigning a name tag. Hi, I'm object A, and no matter where I go, I still represent object A. Let's lock in what we just learned about the this keyword once and for all. At the top level in the browser, this equals window. In Node.js modules, this equal to empty object, not global. In regular functions, in non-strict mode, this equal to global object. In strict mode, this is undefined. For object methods, this refers to the object before the dot. Passing methods as callbacks, they lose this. You can use .bind to fix it. .bind permanently sets this to the objects passed as argument. Arrow functions don't have their own this, they inherit this from surrounding scope. Objects don't create scope, only functions, classes, or modules do. If you found this helpful, please give this video a like and subscribe for more beginner-friendly JavaScript deep dives. Thanks for watching, and I'll see you in the next one.